So memorizing the unit circle. Like anything that you memorize, it's really hard to just try to absorb a large amount of information all at once. Like when you look at the unit circle with all the coordinates and the angles and the degrees, that's an overwhelming amount of information. But as I'm sure you've already probably noticed, there are a lot of patterns in the unit circle that are going to make it easier to memorize. And that's actually just how your brain works. Your brain makes connections and patterns. And so our goal today is basically to take, all of the unit circle and figure out the things that are repeated and the things that you'll need to keep track of. And it actually is going to end up being a lot easier to memorize the circle than maybe you think. So I'm gonna guide you through that. So I'm gonna give you a paper that has basically two blank unit circles on it. On one side, it has little parentheses here. We're gonna fill this out. The one on the back, actually, I want you to leave blank on purpose so that as you're doing your homework, you could kind of look at this as a reference to try and imagine what would be there without actually writing on it at all, just so you can see what the circle looks like. So we're working our way towards that, but basically just leave this side blank for now. The first thing I'm going to ask you to do is number all of the degrees around the circle. So turn your unit circle over right now. Try to write out all of the degrees going all the way around. And then once you've done that, then turn over your own unit circle and see if you got it right. If you can't remember one, just skip it at first. Don't turn your circle over and look. Wait till you get all the way through. Be disciplined in that, and then turn it back over and see. Okay? So again, this is like to help you memorize it. So again, we're doing the side with the parentheses. And you'll see on that paper there's a little line down here that says degrees. Put your degrees there. And again, don't look until you've tried them all, okay? You don't know, sir. And again, once you get them all, you can take a look. Or maybe for degrees, you don't even need to look. Maybe you know you got them right. Degrees are probably a little easier at first. Okay, so I'm going to show you how I put the degrees on here, and I'll show you the method that I use. What I do first is I just count by threes, and I do all the multiples of 30. So 30, 60, 90, 120, 150. So I'm just counting by threes, right? I'm thinking like 18, 21, 24, 27, 30, 33, and 36. Or I'm just adding 30 every time. I just find that easy to keep that pattern going. And then because some of those angles ending in 5 are hard to remember, like it's easy to remember, hopefully, that one is 45 degrees. But maybe it's hard to remember, like, wait, is it 145 or 125 or 135? Or is it 215 or is it 235 or whatever? But if you have all the angles up here in 30s, it's just going to be halfway in between those two angles right there. So if I put 125, that's too close to the 120 degree angle. If I put 145, that's too close to 150. So it's right in the middle. It's 135. This would be 225. And this would be 315, halfway in between there. So that's kind of my strategy. You can take it or leave it. Okay. What I want you guys to do right now is see if you can do the angles over 4. So see if you can add those up. Remember how we did that? Remember how we came up with them last? We just added pi over 4 plus 1/4 plus 1/4 plus 1/4. See if you can do that without looking at your circle. Give that a try. Where should you put them?
Like inside here.
Oh yeah, there's a little space next to the degree. Yes, that other dash on there. Yeah. Yeah, turn and check with your neighbor on these angles over 4. See what they got. See how they ask them how they remembered which one was where, what they were thinking about.
Oh yeah, for these ones, it's just like each fourth is 1/4. So I just did like 1/4. I just tried to honestly, I just kind of once I got to the later ones, I just counted them back. Yeah.
Okay, so I'll tell you guys how I did this. Is remember that every time we go 45 degrees, we're counting 1/4. So it's 1/4. There's pi over 4. 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. And then we don't actually want to leave those angles written like that, so we'll simplify those, but that's the idea. That's pi, that's 3 pi over 2, that's 2 pi, that's pi over 2. And hopefully actually you guys remember, because we've seen those angles a lot, pi over 2, 3 pi over 2 pi, 2 pi. Do you guys notice any patterns here with these angles over 4? What's that? Yeah, minus pi over 4 to get to each of them. Okay. Yeah. Any other patterns? Well,
I guess for like the pi over 4's that are not in the axis, you add to pi over 4?
Yeah, this distance there is 2 pi over 4. Yeah, we're counting by 2's, yeah, to go. Because those are actually the angles that are over 4, right? Like the ones on the axis are not written as over 4. So if we're looking at those 4 angles, yeah, if you add 2 to the top every time, yeah. What else do we notice? Pi, 1, 3, 5, 7. What do we notice about those numbers? They're odd numbers, right? Those are odd numbers. So 1, 3, 5, 7, we're just counting odds. If it was an even number on top, it would simplify, right? So if you remember those numbers in the middle, the angles over 4, those are odd numbers. That can help with that as well. Okay, so see if you can do the same thing by counting by sixths. So we're going to add pi over 6. Every time we go 30 degrees, we're going to add pi over 6. That includes pi over 2, which we already have written down. It's going to include some of those, but just count by 6. Give that a try. Okay. I want you guys to count with me just by ones, okay? So this is going to be, say it all together here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? That's how we're counting. We circled every angle except which ones? The ones over 4. Okay? So those are the angles that go by 6. There's 12 of them. So pi over 6, that's 2 pi over 6, pi over 3. 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6. Notice I'm just simplifying them. 9 pi over 6, 10 pi over 6, 11 pi over 6, and we already have 12 pi over 6. So if you can count fractions, this is easy mode. Turn to your neighbor. Do you notice any patterns about the locations of the angles over 3, over 4, over 6, over 2?
The ones over 6, the ones you can't simplify are like here to here, like one away. But then like once you're in here, like 4 over 3. Yeah, this is like 2, so you just simplify. Yeah.
Okay, so can you guys point to where the angles over 3 tend to be? Or not tend to be, where they are, right? Top, not very top and very bottom, but right next to the top and bottom. Those are your angles over 3. So they make like almost like a tall rectangle here. Sometimes it's helpful to draw that in, sometimes it gets confusing. I like to draw it and erase it for you guys. So 3's are at the top. What about the angles over 6? Where are those? Yeah, those are here and here. They're closer to the x-axis. Okay, 1/6 is smaller than 1/3. So if we go up 1/6, we're going up not as far as 1/3. Where are the angles over 4? Right in the middle, right? Angles over 4 right in the middle. Those are 45 degrees. Right in the middle there, right between those two. Where are the angles over 2? Top and bottom. And where are the whole numbers? Those are out to the side. Okay, so a pattern you might notice here is check out the denominators. 6, 4, 3, 2. They get smaller as you go to the top. It means the fraction gets bigger, but the denominator gets smaller. 6, 4, 3, 2. Or as you go to the bottom, they get bigger. 6, 4, 3, 2. 6, 4, 3, 2. With your whole numbers on the sides. What do you guys notice about the fractions of these angles? Look at the different fractions we're making here. 1/6, then 7/4 and 5/3. Do we notice any patterns about those? Maybe patterns about the numerator and the denominator. Turn to your neighbor. What do you see? Think about the numerator and denominator. Okay, I think the most important pattern here to notice, all of these fractions, what's bigger, the numerator or the denominator? The numerator. These are all improper fractions, right? Improper fractions is where the number on top is bigger. It means that fraction is greater than what? Greater than 1. Where's 1? Right there, right? That's pi. That's our 1. So everything below it, the numerator needs to be bigger. Everything above it, the denominator needs to be bigger. What about all the numerators in the first quadrant? What are they? They're all pi, right? They're all 1. They're all 1 pi over whatever. That's first quadrant. They're all 1. For all of these, 2/3 is 1/3 away from 1. 3/4 is 1/4 away from 1. 5/6 is 1/6 away. So they're just 1 short of making 1 right there. Third quadrant, they're 1 extra. Because we hit 1 halfway through, right? So we almost get there, then we pass it. Fourth quadrant, these angles all almost equal what? Yeah, they're almost 2, like 12/6, 8/4, 6/3. So they're just 1 below that. Because where's 2? It's right there. Okay. Look at the triangles on your unit circle. Take a look at those triangles. Turn your unit circle over. Look at the sides that you labeled. The one you made last class. Okay, so remember we have 2 types of triangles. We have a 30, 60, 90 triangle. What's the short leg? Long leg? √3/2. We have our 45, 45, 90 triangle. Both of those legs are √2/2. And so that's where we're getting all these coordinates from. Think about these numbers. This is not a trick question. 1, 2, and 3. What's the biggest number? 3. What's the smallest number? What's right in the middle? Okay. So √1, √2, √3. Are they still in the same order? Biggest to small, or smallest to biggest? √3 is bigger than √1. √2 is right in the middle. Okay. What about over 2? Are they still in order from smallest to biggest? 1, 2, 3? Yeah, they are. What does √1/2 equal? It's 1/2, right? These are the 3 numbers. They just go 1, 2, 3 in order. So if I'm trying to do the coordinates for this angle right there, oops, I didn't mean to erase it. That angle right there, I see I go over a short distance, up a long distance, which tells me my coordinates are short, long. If I'm doing 5 pi over 6, I see I go back a long distance, up a short distance. So that's negative √3/2, 1/2. Long, short. What do these √2/2 angles get used for? Or, sorry, not angles. Sides. What do they get used for? Yeah, the 45, 45, or the angles over 4. Okay? Well, think about that. What's 2 plus 2? 4. 45 starts with a 4. So those root 2 over 2 angles, they're going to go with these here. Where are these angles located over 4? In the middle. Root 2 over 2 is where? Of those numbers right there? In the middle. Okay, how about that? So all of these are just going to be variations of root 2 over 2. How do we know if it should be positive or negative?
It's like which quadrant it's in.
Yes, exactly. You guys are both right. Its location, which quadrant it's in. Exactly. Okay, so without looking at your circles, so you do the coordinates for all of these. Okay, so here's the coordinates. Obviously, there's the patterns that we just talked about, but in addition to just thinking like 1, 2, 3, small, medium, large, all the angles over 6, the root 3 over 2 is going to go first. Why? Because they're out to the side, so they have a longer x coordinate. So they have root 3 over 2 as their x coordinate. Positive or negative, depending on which way they're going. The angles over 3 have root 3 over 2 as their y coordinate. And I see I made a mistake in there. They have root 3 over 2 as their y coordinate because they're up higher. So the long leg is the y coordinate for them. And so anytime you use a root 3 over 2, it's also going to go with the 1/2. The angles over 4 just get root 2 over 2 for all of them. Okay, the only ones we really haven't talked about now are just the angles on the x and y axis right there. What is this distance right there? What's the radius of our circle? 1. So that means this is 1, 0, and that's 0, 1. That's negative 1, 0, and that's 0, negative 1. Okay. Your quiz next class is going to be writing all of this from memory. We just went through a lot of patterns. I basically talked you through how I do it. I do the degrees first, then I do the radians, starting with the angles over 4, then the angles over 6. Then I actually do the coordinates for the angles over 4 next, because those are easier. Then I do usually the angles over 6, then the angles over 3. Those order doesn't really matter. Then I make sure I get these. Okay? This is what your quiz is going to be. There's the answer key. You're going to have it memorized. Okay. Let's remind ourselves how we use the unit circle. And you can just write this on there. Because the radius equals 1, sine of theta is just the y coordinate. Cosine of theta is just the x coordinate. Because if sine is supposed to be y over r and we do y divided by 1, that's just y. So cosecant is just the reciprocal of y. Secant is the reciprocal of x. And the only ones that are the same as they were before is that tangent is y over x. And cotangent is x over y. So those are the same. Yeah, we're going to do some practice problems right now. We're not going to do all these. I'm going to circle some for us to do first. Okay. Just start with the ones that I have circled there, using what we just talked about. Hey.
This is like sine opposite of the thing. I just did the opposite one half. So it's like the shorter side.
Okay.
So I just did like one half, and then this is one. So you
Let's talk about these.
this is the bottom. And I just did one.
So here's what we need to do. Here's what we need to be thinking. Sine is the y coordinate. Cosine is the x coordinate. The coordinates, we have a few options. They can be 1 over 2, root 2 over 2, or root 3 over 2. Remember, those go small to large. And there's just a couple other to remember as well. It could be 0 or 1 based on the location. So this is just smallest to biggest right here. So when I think of 30 degrees, I know it's there, either because I'm looking at my unit circle or because I have it memorized, which I do. Do I need the x or the y? We need the y coordinate. Notice the y coordinate is the short leg, so that's 1/2. I picked the smallest coordinate for that. The main ones you need to remember are those three. 0 and 1 are only going to be for the angles that are on the axes. Okay, so when I think of 135, I know that's based on a 45, 90 triangle, so the answer is going to be root 2 over 2. The question is it positive or negative? It's negative because 135 is here, and cosine is the x coordinate. So I'm going left. When I get to pi over 2, okay, this is one of those angles that's on the axis. So the coordinates there are 0, 1. Which one of those do I want for cosine? 0. We want the x coordinate. Cosine 7 pi over 4, I know I'm going to use root 2 over 2. These are all sine and cosine, right? So that's all x and y. Is it positive or negative? It's going to be positive. We're going to the right. Cosine 5 pi over 6, okay? 5 pi over 6, that's an angle over 6. It's close to the x-axis. I need the x-coordinate. I can see that that's the long leg. So that's negative root 3 over 2. Sine of pi over 6, well, this is the same as 30 degrees, but that's right there. I need the y-coordinate, which is the short leg. It's 1/2. So we don't want to think about opposite over adjacent. We don't want to think about opposite over hypotenuse. If we're doing a unit circle, we want to say, okay, sine is y, cosine is x, which means it's going to be one of these three numbers, 1/2, root 2 over 2, root 3 over 2. These are only for the 45-degree angles, the angles over 4. And there's your short leg and your long leg right there, based on where they are. You know.
Will we have is this gonna be on the quiz?
This is not going to be on your next quiz. This is going to be on the quiz after that.
Oh, okay. And then on like the quiz and test, are we first writing our memorized unit circle and then doing the whole thing?
You only will have to write the whole thing out once. So yeah, potentially more than once. Next class, your quiz is to write the whole unit circle out from memory. The only way to pass that quiz is to get it 100% correct. If you miss anything, if I write 30 instead of 30 degrees, that's an F. It's a 0. If I miss 1 radian, if I miss 1 coordinate, if I miss 1 negative sign, it's a 0. The only way to pass is to get 100% correct. But you can retake it as many times as you need to get 100%. The most I've ever had anyone retake it is 4 times. But they got it eventually. So everyone will end up with 100% on this quiz. It might not be next class. It might be the class after that. It might be more hot time, but you will get it. You need to memorize your unit circle. Every year, there's a few folks who memorize it basically just to write it out, but then they don't retain any of this. They don't make any effort to actually learn this. They do really poorly for the next 4 months. So the next 4 months are only easy if you know this. Otherwise, it will be impossibly difficult, just so you know. Don't pack up. We're not done. When we talk about negative angles, like these right here, what we want to remember is that these are vertical reflections of the positive angle. So if 45 is there, negative 45 is here. It's in the same position as 315 or 7 pi over 4. And so when I say do sine of this angle, it's negative root 2 over 2. It's a 45-degree angle. It's one of those numbers, the middle numbers. It's going down. So negative 90, 90 is straight up, negative 90 is here. What's the x-coordinate there? 0. 315 is there. Negative 315 would be there. So it would be positive root 2 over 2. Again, those root 2 over 2s are only going to be used for the 45-degree angles. Yeah, take a look at the back. Sometimes we're going to see questions like this where the denominator matches an angle that's on the unit circle, but it's too big. It's not on the unit circle. How do we figure out where this angle is? Yes. We're going to find a coterminal angle. We're going to add 2 pi or 360. So if it's negative 35 pi over 6, I'm going to add 12 pi over 6 because that's 2 pi. So I see I'm at negative 23 pi over 6. What I say to myself now is, oh, that's still not on the unit circle. Okay, so add another 12 pi over 6. Now this gets us to negative 11 pi over 6. Okay, that's technically not on the unit circle, but it's a reflection of an angle that is. There's 11 pi over 6, so here's negative 11 pi over 6. It's in the same position. It's pi over 6. Cosine is the x-coordinate. Since it's way off to the side there, it's the long leg. So then it's root 3 over 2. That would be my process for all of these. You just have to add or subtract 2 pi until you're back on the unit circle. Our quiz next class will be at the end of class, so we'll do a lot more practice with the unit circle and finding the angles and things like that, so that by the time you write it out, you'll have some more reps. And then the class after that, well, this is all sine and cosine, so finish this for homework, do this for homework, and then there's also delta math to go with this. I'll be collecting this next class, just so you know. Now you can back up.